Okay, hi scholars, welcome back to the channel. Today we're going to be looking at algebraic terms, right? All these words that we use in algebra that we really need to know what we're talking about when we call these words, because that's how we're going to know what to do with them, all right? Now, much of math, believe it or not, is steeped in language. If you understand the language of math, then you are well on your way to actually solving the problems, right? Doing the operations that you're required to do. Because things are named based on what they are, right? Plain and simple. So sometimes you should just go and get your dictionary. If you're doing math, you come upon a term, you come upon a new topic, get the dictionary, look for the keywords and see actually what these words mean and why these terms got these names. And it will help you in understanding the concept and understanding how to approach the problems. So I'm going to go through the key words, the key terms that are used in algebra at this level, and we're going to look at what they mean, what they refer to. So let's start with the word term. Alright, so when we're doing algebraic equations or expressions, we encounter terms. A term is a number, can be just a number, can be a letter, or a combination, numbers and letters combined, as well as powers combined. And we look at all of these words that I'm calling separately. So a term is a number, a letter, or a combination of both. So 3x is a term. 5 by itself is a term. It's called a constant term. And I'll explain that a little later. 4/5 y together, that's a term. Negative 6pt is a term. Negative 3 is a term, right? So all of those by themselves, all of these by themselves are terms. Coefficient, right? Coefficient is the number, the numerical or number part of the term. So if we have a term 10pq, the 10, the numerical part of the term, is called the coefficient. If we have negative 2y, the negative 2 is the coefficient of that term. X, suppose we just have x, or y, or p, or whatever the letter is, or negative x. If we just have x, it does have a coefficient. It has a coefficient of 1. So in algebra, usually when the terms have a coefficient of 1, we don't write the 1. We say it is understood. However, you must remember that the 1 is there, because if you need to add or subtract terms, you are going to have to work that 1. Whether you're adding or subtracting, it's 1. Remember that that coefficient of 1 is there. Or let's say it's negative x. What would be the coefficient in that case? The coefficient would be negative 1. The coefficient can be a fraction. It can be a decimal. So you can have half p, where half is the coefficient. Negative 3/4 p, where the coefficient is negative 3/4. Right? Or 2.5x. The coefficient there would be 2.5. So you can express the coefficients as a negative number, a fractional number, a whole number, as well as other numbers. Right? So it's very important for you to know this. So when you see the letter by itself, it does not mean that the coefficient is 0. It does not mean that there is no coefficient. It means that it has a coefficient of 1, but the 1 is understood. And you must remember that 1. So if you have x plus x, that would give 2x, because we have the 1x plus 1x, we add the coefficients, and we have 2x. Alright, so remember that. Now, a variable. That is the letter that's attached to the number in a term. The variable represents an unknown value which can change or vary. That's why we call it a variable. What does it mean to vary? To change. So when you look for these words in the dictionary, you'll have a clearer understanding of what we're talking about. Why do we call these variables? They vary. They may change according to what we substitute the value for. Right now, the variables can be substituted by numerical values, right? And usually in algebra, the variable will represent an unknown value, which most times we're trying to find. You know, in algebra, they say you're trying to always find this elusive x or this elusive y. And persons will say, why do we even need to find x and y? How is it going to benefit us? Well, later on, we're going to see how we apply algebra to real life. We're going to look at some real life situations and how we can use algebra to solve them by using an unknown value, a letter, to represent that numerical value that we're seeking. And we have many different ways of manipulating that, many different methods of manipulating that to solve, to find what that unknown value is and make it known so we can apply it to the problems that we have in life, right? So application of algebra, very crucial. A lot of persons question, why do we even need to do algebra? Well, we're going to see why we need to do algebra. All right, so that's coming up. So we're saying the variable can change. We can plug in or substitute numerical values to take the place of the letters. So where you see 3xy, we have two variables here, x and y. And when they're together like this without a plus sign or minus sign, it means you are multiplying. So whatever you're going to plug in for x or y, you are multiplying those by 3. Right? So there's a method in algebra that we use called substitution, which we will get to, where we plug in actual numerical values for the variables and we multiply it by the coefficient, or if it's two variables together, we multiply the variables together. So what is the variable here? We have two variables, x and y are variables. 9p, the variable is the p, negative 5w, so the variable would be the w. Alright, so the 3 would be the coefficient here, the 9 would be the coefficient, the negative 5 would be the coefficient. Now suppose we have y is equal to 2x. Y is equal to 2x. Here we have two variables. Y is called the dependent variable and x is called the independent variable. Now again we get our dictionary and we find out what does it mean to be dependent? What does it mean to be independent? When you are dependent on someone or something, that means you're sitting around waiting for that person to give you something, or what you are depends on what the person is, right? So, or what you are depends on what that thing. So the thing has to change first for you to change if you are dependent on that. So that's what this means. Y changes if x changes. Y is depending on the value of x. The value of y depends on what x is. Okay? So in this case, y is equal to 2 times x. Whatever we substitute x for, y will change accordingly. So x is the independent variable. It's over here by itself doing its thing. but y is dependent on the value of x, because whatever x does, y will either suffer or benefit, right? It is depending on what's happening with x. Alright, so let's look now at the index. Singular, index, plural, indices, right? Singular index, plural, indices. And there are other names for the index. We can refer to it as a power. So we say something is raised to the power of. Or we can refer to it as an exponent, right? It's an exponent. What is the index? What is the power? What is the exponent? It's a small number written to the top right of a term to tell what power that term is raised to. And what we mean by that is we're going to multiply that term by itself. So look at this. We have 2x squared. This is how we call it. This is the power. The 2 here, this small 2, remember we said it's written as a small number. So you see different from the other part of the term. It's a smaller number to the right, the upper right hand of the term. It tells you how many times you're going to multiply the term that's immediately before it by itself. So this does not mean you're going to square the 2, you're going to multiply this 2 by itself. This is immediately following the x. So it's only the x that you're going to multiply by itself. If we wanted to multiply the 2 by itself also, if we wanted to square the 2, we would write it like this. In bracket and square everything. Right? So you'd have to look out for that bracket, which would indicate everything in the bracket is being squared. Other than that, the power applies to the term or the coefficient, the variable that's immediately in front of it. And it tells you how many times you're going to multiply that number or that letter by itself. Therefore, negative 9y cubed. This is how we call it. When it's a 3, we call it cubed, or we say raised to the power of 3. When it's a 2, we say squared or raised to the power of 2. So negative 9y cubed would mean negative 9 times y times y times y. 5 cubed means 5 times 5 times 5. It does not mean 5 times 3. That's a common error people make. It does not mean 5 times 3 or 3 times 5. It means 5 times itself times itself. 5 times 5 times 5. 5 raised to the power of 3 or 5 cubed. If we just have a letter by itself, in the same way as we're saying x by itself has a coefficient of 1, which we don't bother to write, it's understood. Likewise, x by itself also has a power of 1. X to the power of 1. We don't write the 1, but you must remember that it is there. Okay? Because if you have x times x times x, we are going to add the powers, because when you're multiplying and the base are the same, we add the powers. So that's 1 plus 1 plus 1, that would give x to the third power, x to the power of 3, or x cubed. So we must remember that power of 1 is there. If we just see x by itself, it's x to the power of 1, and there's also a coefficient of 1 in front to the left of it. Alright, so that's the power, the index, the exponent. What's the constant term? Alright, so let me circle the powers here, just so that we understand which part of it is the power. So it's the little number at the top, right? The little number to the right upper part of the term. The constant term is a number without a variable. The constant, what does it mean to be constant? Grab your dictionary again. Look in the dictionary. What does the word constant mean? It does not change. It remains the same. It's not affected by anything around it. Remember, the variables are affected by what's going on depending on what numbers we plug into them. The constant term remains the same. It's just a number. There's no variable there. So if we have this expression, 3x plus 2, 2 is a constant term. That's the number by itself there, no variable attached. The 3x has a coefficient and a variable, and separated by the constant term by this plus sign here. Negative 5y minus 6, the negative 6, that is the constant term there. 6x plus 17, that's the constant term, the positive 17. Now what's an expression? To express means to just state what is. When you express yourself, you just say how you're feeling, what is happening. The expression tells us what is happening, what are we doing with the terms. So 9x plus 7, that's an expression. It's a combination of terms, and the expression is separated by plus or minus. So it's one or more terms separated by a plus sign or a minus sign. So that's an expression. It's just telling you what we do. It says we're multiplying x by 9 and we're adding 7. That's the expression. It's just telling us what we are going to do. This says negative 3x squared minus 5x plus 9. It's telling us what we're going to be doing to our x's. We're going to square the x's and multiply by negative 2. We're also going to multiply the x by negative 5, combine those and add 9. The expression is telling us, expressing to us what to do. Alright? 2x plus 3x, 2y plus 3xy minus 4. So this expression has two variables, x and y, which we are going to plug in, and this is what we're going to do. So guys, it's very important that we know our mathematics, our language terms. I firmly believe when you're doing math, your dictionary should be right beside you. And the more you understand the meaning of the words, the more you will understand the concept of the mathematics that you're doing. Right? So you will notice most times when I'm introducing a topic, I will go through the terms and explain and tell you what's the connection. Why was this thing called that particular name? So we have a couple more terms to look at. The equation. When an expression is made equal to an amount. So this expression becomes an equation simply by putting equal to something. This is equal to something. 2x plus 6 is equal to 11. It's now an equation. Equation coming from the word equal. What is it equal to? Negative 4y minus 6 is equal to 14. Right? That's an equation. The inequation now, instead of the equal sign, we have one of these. Not equal to. So we could say 2x plus 6 is not equal to 11. That's an inequation. So the prefix in means not. It's not an equation. It can be not equal to, it can be greater than, it can be less than, greater than or equal to, less than or equal to. So once you see any of these signs, an expression followed by one of these signs and a result, then it is an inequation. It's not an equation. There's no equal sign there. It's either saying not equal to, greater than, less than, greater than or equal to, less than or equal to. Alright? Now an operation. What's an operation? We don't mean when you're going for surgery. Remember, words have different meanings. Right? One word can have several meanings. So when we're talking about an operation in mathematics, we don't mean you're going to be wheeled into the surgery for them to cut into your body. What we mean is we're telling you the rule that you're going to apply to the terms. Are you going to add them? Are you going to subtract? Are you going to multiply? Are you going to divide? And there are other operations, many other operations, right? But these are the four basic operations of arithmetic: multiply, divide, add, subtract. So it tells you the rule. What are you going to do to the terms? So it's the inputs. You're plugging in these values and you're doing this to them to get the output or the results. Right? Now finally, you need to remember, when you see a plus sign or a minus sign in front of a term, that sign goes with the coefficient that precedes it, the coefficient or the variable that comes. The sign goes with the coefficient or the variable that comes after it, that follows it, that it precedes, right? That the sign precedes. So for example, 9x, when we start with a positive term, we don't put the plus sign, but there is an imaginary plus sign. There is a positive 9x. This is a positive 7, negative 2x squared, negative 5x plus 9, a positive 9. So when we get to, for example, changing the subject of the formula, or doing simultaneous equations or stuff like that, we need to remember these things, that the sign goes with the variable that it precedes. Or in other words, the sign goes with the variable or the term or the coefficient, whichever that comes after the sign. They go together. If you're moving one, you're moving the other. Right? So that's very important. Right? So these are the basic terms used in algebra. Write them down. Remember them, understand them, right? And you're going to need to know these for all the operations that you're going to be doing in algebra, so make sure you know them. If you have benefited from this video, please just drop a comment to say thank you, miss. Please share the video to others so they can benefit as well. And if there are any other topics that you'd like me to do a video on, I'll be glad to do that. Just drop a comment and let me know. And I'll see you in the next video.